All right, welcome back. We're finishing up section 3.5. We started in the previous video talking about how to prove that an argument is valid or invalid by making a t-table, but oftentimes you won't have to make that t-table, luckily, because that's kind of a pain, right? Or sometimes you can reason it out and kind of think about it. But the good news is we have a list of some commonly used arguments. Some that we've already shown are valid or invalid. So the next part of your notes, page 3, you have a place to write these in. And again, you can find these in your book as well. We've already kind of talked about the first two, actually. These are the two valid arguments that we proved in the previous video. One's called the Law of Detachment, and it says if P leads to Q, and then P happens, therefore Q would happen. And that kind of makes sense if you think about it. So always valid. If you can represent it symbolically and say this is a valid way to say things. It makes sense. So you could prove it again. You see that in the previous video. And all these have Latin terms as well, which is kind of interesting. That I didn't write those down, but they're in your book if you're interested. The next argument is called the law of the contrapositive. Now, you might remember we saw the word contrapositive, and some of these others we're going to recognize from 3.4. We talked about how, is it okay to say things backwards or forwards or negate them? What's up with that? Does it make it valid? So that's where we're going to show that here in this video. And actually the contrapositive was where you'd switch the order and negate each part, and that actually is okay. That does wind up being a valid argument, and again, you could prove that on your truth table. We actually did. So it says, if P then Q, then you negate Q, and it leads to not P. So that actually does work out to be a valid argument. The law of, the law of syllogism, or it's sort of like a transitive property. It says if P leads to Q and or plus Q leads to R, then P should also lead to R. The valid or the logical conclusion would be if we have a P then Q plus, then we say Q leads to R. So it makes sense to say P also would lead to R. Therefore, P leads to R. That's called the law of syllogism. Okay, there was one more valid one that I didn't get on this board, so let me write that one down. So the fourth one is disjunctive, if I can spell it, disjunctive syllogism. Okay, disjunctive syllogism says P or Q. If I say you can do this or you can do this, the or statements, that's forgiving one, says you can do either or and it's true. So they say, so it wasn't P, therefore it must have been Q. And this also works in reverse. It could be either or of these. So if we have a P or Q statement, and then it wasn't P, negate P, not P, therefore it makes sense it must have been Q. And again, this could also work if we said P or Q. So if we said it wasn't Q, therefore it must have been P. So that's an equal form of saying that. It's just saying it could be either one of those. So if it wasn't this one, therefore it must have been the other one. All right, those are the valid arguments on our official list. Now we have some invalid ones. And these should look familiar to you from 3.4 because we talked about the converse. That's where you switch the order of things. Is it okay to say if P, then Q, and then just say it backwards, if Q, then P? And it's not okay. So the converse is not okay. You can't just switch the order of things. If P then Q, just because of Q doesn't mean it leads back to P. You can't do it in reverse and count on that being a valid argument. I mean, it might be sometimes, but it is not valid to always say that. That is not an always true argument. Same thing with the inverse. You can't just negate both parts and that be a true thing. So if we have a conditional P then Q, if P then Q, and then we say it's not P, therefore it's not Q, that is not always a valid argument. Again, all these can be proven with that truth table, but just trust me, I guess, for now, say these are on the list of, just say if the question in your homework is this a valid argument, you can symbolically show it as either one of these whenever you decipher it and say, hey, that's invalid. I don't have to prove it. I already have that on my list, but prove it if you like. All right, so we got a little list going, and feel free to add more as you do your homework to things that you can look back to, and it'll help you as you do your homework. All right, so that is that page. Moving on, now we're going to practice that. So, you know, when we get to activity, I like for you to pause the video, do your activity, to give yourself a chance to practice what we're talking about, see if you're getting it. So number 3, translate the argument into symbolic form and then tell me if you can find this on the list, if you already know if it's valid or not valid. So it says, if the car is a road runner, we'll call that statement P, then the car is fast. So we got it, if it's a road runner, then it's fast. So if P then Q, then they make a statement, the car is fast, that's statement Q, therefore it must be a road runner. So no, you can't say that in reverse, right? It's not always true. I mean, it might be true, but it's not always true. If we made a truth table, it's not an always true thing. So they've reversed this, if P then Q, so then they said Q leads back to P, and that's on our invalid list. That's the fallacy of the converse. They've switched the order, so you can't just do that. It's not always the case. It doesn't always work out to be true. So we'll say, that's A part, show it symbolically, and then B part is call it, by its name. It's the fallacy of the converse argument. Invalid. Fallacy would mean it's invalid as well. All right, trying it again. The next one is, if I get my child to preschool, we'll call that statement P. If I get my child to preschool by 8:45, then I can take the 9 a.m. class. We'll call that statement Q. Then the next sentence says, if I take the 9 a.m. class, that's what we just called Q, then a new thing, then I can be done by 2 p.m. That's a new thing. There's 3 statements going on there. There's the, if I get my child to preschool by 8:45, Q is, then I can take a class by 9 a.m., then we repeated that in the next sentence, and then we added, then I can be done by 2 p.m. So there's 3 things there. Therefore, then the third sentence is, if I get my child to preschool by 8:45, we call that was P, then I can be done by 2 p.m., which is R. So that one is on the list. Compare your list. This is that kind of transitive property. If a P leads to Q and a Q leads to R, then P also leads to R is a logical conclusion. It can be proven. So that is Law of Syllogism. You should write for B part. Law of Syllogism. Okay, always feel free to pause when you need pause. Practice this will help you. Okay, number 4. Continuing the same idea for the rest of the pages. All we're doing is practicing these arguments, see if we can match them up. We will go for a bike ride, and we'll call that P. Notice the word or, that's our B. We will go shopping, I'll call that statement Q. Next line or next premise, we do not go shopping. So we negated Q. Is it logical then to conclude we go for a bike ride P? Is that on the list? If P or Q, it says we're going to do one or the other. You think about it. We will go for a bike ride or we will go shopping. So we didn't go shopping, so it makes sense we must have gone for the bike ride. And that kind of flows like something you might say. We're going to do this or this. We didn't do that one, so we must have done the first one. That is on our list. It's called disjunctive. I don't know about these labels, but it is what it is. Disjunctive syllogism is what that's called. And again, that is on your paper and on your list we're making. Okay, number 5. If you pass general chemistry, we'll call that P. Then, if then, so that's the conditional, you can take organic chemistry. That's Q. Okay, next line, you pass general chemistry, that was P. Does that conclude that you can take organic chemistry? Q. Is that on our list? That's actually the first one we did. That's the law of detachment, the modus ponens, one that I mentioned the very first. If P then Q, so P did happen, therefore we expect it to follow. It's reasonable to expect Q. Again, law of detachment, we should write on that. On the list. One of our valid arguments we've proven. Okay, number 6. If Nicholas Thompson teaches this course, we'll call that a statement P, a simple statement P, then, that's our conditional, I will get a passing grade. We'll call that statement Q. Next line or next sentence. I did not get a passing grade, so not Q. Therefore, does it make sense that therefore, Nicholas Thompson did not teach the course? That was P negated. Now, we talked about how this is actually the law of contrapositive, they can negate it and switch the order, and that's okay. That does work out to be true. If P then Q, we negated Q, kind of opposite order, we negated Q, and it led to the negation of P. And that would be a valid argument. That's the law of contrapositive. Contrapositive. It's a valid argument. You can say that and you'll be talking well. You'll be talking correctly, validly. Okay, two more. Number 7. Supply what you believe to be a logical conclusion. Oh, okay, so we're switching gears a little bit and saying, can you complete what would be a logical conclusion with these two startups? This plus this, what should you conclude based on your valid arguments? All right, and valid arguments that we're aware of on the list already. We won't throw something at you that we haven't talked about on these two, so you should recognize the argument. All right, if the temperature hits 100, we'll call that P, then we will go swimming, Q. We did not go swimming, so negating Q, therefore, what should you be able to conclude? Something on your list that looks like this, and then what? So take a minute and think about that if you haven't already. But this looks like the law of contrapositive. If P then Q, negating Q, then negating P is the logical conclusion there. So law of contrapositive, we have that one on our list. So our logical conclusion in words is, it's not P, but in words it would be, well, the temperature must not have hit 100. So you write out the temperature did not hit 100 degrees. If you think about it, that sort of seems like a logical thing. If you said to someone, if a temperature hits 100, then we will go swimming. So if you didn't go swimming, the temperature must not have hit 100, right? So that seems logical to conclude that. All right, number 8, last one. If I can get Nick to his piano lessons by 3:30, there's a statement, statement P. Then I can do my shopping. We'll call that statement Q. Next line. If I can do my shopping, that's Q, right? Then we do not need to order pizza again. That's a new thought, so we'll call that R. So we do not need to order pizza again. Therefore, what can you conclude? Leave that open to look at your list, what you think, or just thinking about it, what seems logical. And we've studied this one. If P leads to Q plus Q leads to R, then we can say P also leads to R. So this one's on our list. It's called, I have Disjunctive Syllogism. Isn't that the Disjunctive Syllogism? So that is on our list. Is the valid conclusion for this setup is this. Saying this in words, P was, what was P? If I can get Nick to piano lessons by 3:30. So that statement P, then we won't have to order pizza again. If P then Q, plus Q leads to R, P should lead to R. Kind of the transitive property or disjunctive syllogism in this language. And this was, if we can get Nick to his piano lessons by 3:30, then we won't have to order pizza again. All right, so I hope that helps.